You see how this works? Okay. You got to mute yourself, guys. Mute it.
We just gotta turn our volume all the way down.
Or mute it. Or don't join audio, whatever it is. Okay, guys, graphing lines not in y equals mx plus b form. Okay, they're not in that form. So we're gonna have to do a step or two to get it in that form, and then we'll get a little bit of review on graphing lines. Okay. So we're here, okay? It says these are all linear equations, okay? All of these are lines. You have to rearrange the equations so that they are in slope-intercept form, which is y equals mx plus b. We need to put them in slope-intercept form so that we can graph it. If it's not in slope-intercept form, we can't graph it. Okay? And I put a little hint here. Your goal is to get y by itself because we want it to be y equals, and then the rate of change term, and then the y-intercept. Okay? Okay, so if I'm looking at the first example, it is negative 2x plus y equals 3. I only want a y on this side. So this is kind of like solving equations, but we're not really solving. We're just moving things across the equal sign. Tell me what you have to do when you move a term across the equal sign. You got to do it to the other side, but how? Do I subtract 2x? You have to do the opposite. You add the 2x because I want to move it off of that left side so that I'm left with just the y. But then I need to add it over here to the other side with the 3. So now on my left side, the only thing I have over here, since I got rid of the negative 2x, is y, which was I want to see y equals. Now you don't tell me 3 plus 2x is 5x's. The 3 doesn't have x's. Okay, you can't combine these together. They just stay separate. Okay, keep separate. Because they're not like terms. Which term would I want to put first? 1. The 2x or the 3? 2x. Why would I want to put the 2x first? That's got the variable with it. That's the rate of change. I'm trying to go into y equals mx plus b. So I'm going to put that slope term first. And then I'll put plus 3. Now it's in y equals mx plus b. So all I had to do was add the 2x to the other side and just write it in slope-intercept form. Okay. How do I start graphing this?
We start at the 1.
Okay, which is what?
3.
Okay, so I'm going to put a little arrow here. Start on y-intercept. So I'm going to go down here. Always start at the origin here. So that's 0. So I'm going to go 1, 2, 3. That's my first point. That's your start point.
Yep.
Okay, since the slope is just 2, what can I put underneath it?
1.
A 1 over 1. So 2 over 1. Okay, so I'm going to put under a 1 underneath this 2, because 2 divided by 1 is still just 2. So that you can see the rise of 2 and you can see the run of 1. So that means I'm going to go up 2 and then over 1. Up 2 over 1. So I'm going to do that. Up 2 over 1, plot a point. Up 2 over 1, plot a point. Up 2 over 1, plot a point. If you wanted to be accurate and plot more points, you just do the opposite. And instead of going up 2 and over 1, you go down 2, back 1. Down 2, back 1. Down 2, back 1. Okay, and you could just keep doing that. There's my line. It starts at 3 on the y-axis, and the rate of change is up 2 over 1. Up 2 over 1. Up 2 over 1. Positive slope, so your line can be increasing. I love seeing some of you guys go ahead and try number 2. That's awesome. Number 2. Well, let's give a minute. Some people are still finishing up. Don't forget to connect the dots here. Okay, we're not just graphing points, we're graphing lines. Good. All right. Number 2. It says y plus 1 equals x minus 3. The only thing I want to see over here is y. I need to get rid of the plus 1 then. Minus the 1. And then I'm going to minus the 1 on the other side of my equation. 1 minus 1 cancels out over there. That was my goal. Now I'm left with just y equals on that side. Awesome. That's what I wanted. Okay. So the -1, I can combine like terms here. There are like terms here. This is CLT. Combine those like terms together. Okay. I can't subtract 1 from an x, but I can subtract 1 from a -3. Okay. So I just bring down my x, and then it is minus 4. Yeah, you got to think about a number line. If we're at -3, we go back one more, we're at -4. Always use that number line. I have to visualize a number line because it's so easy when you're dealing with negative numbers, right? You're like 3 and 1, I see minus signs 2, right? Okay. All right, so here it is in slope intercept form. That is y equals mx plus b, okay? Where do I start at? The y-intercept of -4. So I start, that's my start point. So I'm going to go on my y-axis. I'm going to go down to 1, 2, 3, 4. Okay. Up 1 over 1. If the slope term has just an x, what's the understood number in front of it? 1. Of 1. Nice. So put that 1, and then yeah, let's put a 1 underneath it. Because 1 over 1. 1 divided by 1 is still just 1. So you go up 1 over 1. Up 1 over 1. Those are those. You're just jumping the diagonals. Make sure you start at -4. Don't get caught on that 1. Start at -4. And then you go up 1 over 1. Good job. Good job, Xavier. Okay. Up 1 over 1, up 1 over 1. So I'm just jumping. When it's a slope of 1, you just jump the diagonals, the corners, jump the corners. Okay. Woo. This last one's got the most going on with it. Okay, I might need to draw my line here. There's a lot going on. Okay. So 4 minus 3y equals x minus 11. The only thing I want to see on this left side is the y. What do we move first? Okay, because that 4, put a plus sign in front of it. That is a positive 4. So I need to minus the 4. I need to subtract it. What on the other side can I subtract 4 from? The -11. Okay. So I'm left with -3y is equal to x. This is combined like terms here. And that's going to give me a -15. All right. Divide by 3.
Yeah.
Go ahead and divide by the -3. If you just divide by 3, then you're going to be left with a -y, and then you're going to have to divide by a -1. So go ahead, and if the coefficient is a -3, just divide by the -3. Okay. This is where we're going to divide by the -3, and everything on the other side gets divided by -3. Okay. Hopefully you won't see one this complex, but just, maybe a bonus or something. -3 divided by -3 divides out to 1. So we're left with y equals this right here. Oh, you can divide and multiply anything. Just like when we distribute, we can multiply 10x into a number. You can divide with x's and numbers, okay? If that's a 1, now it becomes a negative 1/3 x, okay? Because this is, I'm really doing 1 divided by negative 3, which is just negative 1/3. Normally, you won't see the negative in the denominator, okay? And then just slap the x on the side, okay? What's negative 15 divided by negative 3? Positive 5, right? So I got to put plus 5. Now I'm looking good. Now I'm in slope intercept form. So we start, that's my start on the y-intercept at 5. So I'm going to go 1, 2, 3, 4, 5. Ooh, now what do I do? Down 1 over 3. This should give you a negatively sloped line. Remember, just make one of the numbers negative. So you start at positive 5. You go down 1 over 3. Down 1 over 3. When you graph that line, it should have a negative slope. It should be decreasing from left to right. That looks good, Perna. Girl, catch up with us. I'm going to assume that you guys are going to study your notebooks tonight, right? Okay. You're going to have to study for this one. And this right here, if you just look through your book of math for chapter 8, you'll be good. Go back through your chapter 8 notes, maybe 3 times. Should be good. 3 times. 3 times. I'm going to go down 1 over 1, 2, 3. Down 1 over 1, 2, 3. 1, 1, 2, 3. Up 1, back 1, 2, 3. Up 1, back 1, 2, 3. 1, 2, 3. Does your line look like this? Somewhat like that. Okay. It's not perfect like mine, right? Okay, guys, I want you to fold that in half and glue that in your notebook. You need to look at chapter 8, section 1, all the way through chapter 8, section 8. All that good stuff in your notebook. It's on functions. It's on slope, y-intercept, graphing lines, linear, nonlinear. So many things. Yay! Let's fail. No. Yes, let's go.